Welcome to EEE/EC301 Digital Electronics, Lecture 11, Part 3. In this lecture, we will discuss about how to design a shift register and how to write the code in VHDL. Okay, so in this question it says write a VHDL process that implements an 8-bit left shift register with asynchronous reset, asynchronous parallel load, and shift enable. Describe the changes required to make the parallel load synchronous. It is not necessary to provide a complete VHDL module. The core process will be adequate. Okay, so this question has two parts. Like you need to design a 8-bit left shift register which has asynchronous reset, asynchronous parallel load, and shift enable. And later on, the second part is you need to make the parallel load synchronous. So first of all, we need to understand how the 8-bit shift register work, and later on what is asynchronous reset, what is synchronous parallel load and shift enable, and what is the truth table for that, right? So if you understand that part, then you can write the VHDL code down. It's pretty easy actually. Okay, so I'll try to give you some basic idea regarding that part. Just look at here. So let's use the laser pointer here. Okay, so this is actually your shift register. Say this is 8-bit shift register. SR is for shift, R for register, shift register. So SR0 to SR7, right? And it says you have asynchronous reset. So this is our asynchronous reset. Okay, asynchronous reset means it doesn't depend upon the clock. Okay, so here you have the clock, so it doesn't really depend upon the clock. Okay, and asynchronous parallel load, the same thing. Load is also asynchronous, so these two is asynchronous, and uh, asynchronous parallel load and shift enable. Our shift enable is also asynchronous, right? So all of these are the input, right? And we have the input from D in, data in. So this is our input, and we need to have another one, data out, right? Okay, so that will be our then entity. Just look at here. Okay, so this part we already discussed. Okay, let me use the laser pointer actually. Already discussed. So we have reset, load, and shift enable. Asynchronous, we have clock. This is our data in, I mean S in, serial in. This is data in. Okay, so this is the truth table. So we have 4 input: reset, load, shift enable, and clock. So among them, the reset will get the priority, the load will get the second priority, shift enable will get the third priority, right? And later on the clock. Okay, so if your reset is high, that means it will be activated. It doesn't really matter what's the value of load, shift enable, and clock, all or don't care. So it will reset the shift register. So it shift register SR will be all 0. If a load is 1, obviously your reset need to be 0. If it is 1, then it will get the priority. That's why it need to be 0. If load 1, it doesn't really matter what other value is, shift and clock is, so it will load the values. So SR, this shift register will load the values, this 8-bit data in, so data in. And if your shift enable is 1, that means shifting, it will shift the values, but it depends on clock actually. Your shift enable is synchronous, so this is basically actually your synchronous, not asynchronous. Only reset and load is actually synchronous. Okay, so if your shift enable is synchronous, that means when your clock is activated, then it is uh, then it will shift the values. What does it mean shift the values? It says left shift, so that means SR0 to SR1. SR1 to SR2, SR2 to SR3, up to SR7, right? So you can say SR from data in, sorry, you can say SRN to SRN minus 1. Also SR0 to S in. So what does it mean actually? Okay, so just look at here. So your SR0 is going to SR1, right? So if you represent it in terms of Sn, so 0 to 1, that means this is 1 bit lesser. This is 1, this is 0. So if you consider this as n, so this will be n minus 1. So it's 1 bit different, right? So if your total is n, so this will be n minus 1. And actually here you are getting the 7 bit, but we have one more bit left, which is this value. You are getting SR0 values from S in. So SRN minus 1 and SR0 to S in. Altogether it's getting 8 bit. Okay, let me clear it in the next slide maybe. We'll clear it in the VHDL module part. So here let me show you how to write the port. So as we already discussed, reset, load, shift enable, data in, data out, as in. So our data out is only output, which will be 8 bit, data in is 8 bit, all others are input, and all of them are single bit. So this is the entity part. So within architecture you need to declare the signal. So internal register we have SR, so we need to declare SR, and this is 8 bit obviously, 8 bit. And also you need to have the connection, so data out. So data out need to be connected to SR to get the values from the SR, right? So after begin we declared the connection SR. Okay, let's check all together how it looks like. Okay, so before writing the architecture part, so we need to understand one more thing. So within process, after begin, we actually check for two things. So after if we check for asynchronous check or asynchronous action, and within the clock we check for synchronous check or synchronous action. So what does it mean? So in our case we have shift enable, which is synchronous, that means it depends on clock, and this other two is asynchronous. So we need to check asynchronous first. So here our asynchronous is reset and load, and our synchronous is shift enable. So our shift enable will check it after the clock, right? So that's our basic, and other things are pretty similar. So this is the skeleton. So if you follow that one, I think it's easier to write the VHDL code now. Okay, so as we discussed already before, so we are transferring S into SR0, right? So this is our 1 bit, and some other values was like 0 to 1, 1 to 2, 2 to 3. So similarly 5 to 6, 6 to 7. So here you will get 7 bit, and this is your 8 bit. So this 7 bit, so you can write it this fashion. So SR6 down to 0. So this is your 7 bit, and SN, this is your another 1 bit. So 7 bit and 1 bit, 8 bit, right? So this part was written as Sn equals Sn n minus 1. If you remember the last slide, I told you I'll describe it in the next slide, right? So this part is, so Sn 7, so this is 6 down to 0, this is 7, so total is our 8 bit, right? So that's the Sn is 8, so it becomes Sn minus 1, that means 7. So this is our 7. So here is our 7 bit, and this is our 1 bit, total 8 bit. Okay, and their process we have couple of other things in the sensitivity list, so we'll discuss in the next. So this is our whole VHDL code right now. This is our library function, which you are already familiar with. This is our entity part. I think you already know that. And this is our architecture part. So in the architecture, we started with signal declaration. Our signal is SR, and after begin, we are connecting, and that on within the process, we have reset, load, G in, and clock. Because just look at here. Okay, so here our architecture is dependent on all of these things. So that's why we put all of them as sensitivity list. Okay, let's check it now, then it will be clear. So after begin, we are checking for asynchronous input. So we have reset as asynchronous, we have load as asynchronous, right? So as it says, if reset is 1, then our shift enable will be 0, as we discussed in the truth table. If reset 1, shift, then SR will be 0, because reset activity means reset to all 0. Then if load is 1, then it's loading the values of data in through data in, right? The shift enable. Now else if we are checking for rising edge of clock. So this part we will check for synchronous section. So we have shift enable synchronous, right? So whenever shift enable is activated, then it will shift the values. So it will shift the value 6 down to 0. This is our 7 bit, and data in the initial bit, if you remember. So altogether 8 bit. So if and if, this if and if, and end process. So we started process here, end process, end behavior. So I think it's clear to you now. And this is the typical the RTL schematic representation, right? Whenever you are done with your code, so if you run it and if you use that on implement design, and after that you have synthesize, so double click on synthesize, then there will be pop-up window where you need to select the second option, not the first one. If you select the second option, it will pop up this kind of windows where it will show you that architecture. So if you look at here, so this is basically your uh, this outer part, this is basically your top level. So you have reset and shift enable clock and all other things, and within that you have the architecture whatever you have described, right? I think it's clear to you now. Okay, thank you.